Okay, hi guys. So this is your tutorial 1 briefing. So I'll brief you through the answer. So question 1 and question 2 is theory question. So this sort of answer all can be found in your lecture slides. But nevertheless, I will just briefly go through with it. So question 1 is asking you to explain the following term and provide the unit. So A, luminous intensity is the power of a light source or illuminated surface to emit light in a particular direction. So the unit is CD or candela. B, luminous flux is a rate of flow of light energy, which is lumen. So C, illuminance is the density of luminous flux reaching a surface. So the unit is Lx or lux. And finally, you have your reflectance is the ratio of luminous flux reflected from a surface to the flux incident upon the surface. So is 1 for shiny and 0 for dark and dull surface. Okay, so part 2, question 2 is name 2 types of glare and differentiate between them. So the 2 types of glare is disability glare and discomfort glare. So disability glare is a glare that lessens the ability to see detail. Discomfort glare is a glare that causes visual discomfort without necessarily lessening the ability to see detail. So if you can see on the picture here, this is the disability glare. So this is a picture of a car beaming their headlight here. So if you were to actually encounter this in real life, you'll find that this sort of glare is very blinding. And then finally, discomfort glare is something that you might encounter in your room because the light is unshielded and is directly facing you. Okay, so this is a different type of glare. Okay, question 3 and up to question 7 is all calculation question. So it's very direct lah. If you have if you have done it, then you'll find that the method to do it is very similar to what you'll find in your example in your lecture notes. Okay, so going on to it. Question 3, you are given a total luminous flux of 1257 lumen. So you have 1257 lumen in all direction is asking you to find the luminous intensity, which is I. So using this formula, you have to just substitute the factors that you know into it. You get 100 candela. So this 4 pi is already fixed. So if the question didn't say anything and just give it to you like this, always assume that W is 4 pi lah. Okay, so question 4. A point source of light has an intensity of 410 candela and radiates uniformly in all directions. So there's A and B. A is asking you to calculate the quantity of flux flowing into a hemisphere. So for this A, hemisphere is half of a circle. So you just divide it by 2, then you have 2 pi lah. So using the same formula in which you used to find the luminous intensity previously, you just shuffle the formula around and then you will be able to find what is the luminous flux using the known factors. So you put the value in 410 and then 2 pi, you'll get 2576 lumen. Okay, so for part B, you have to calculate the average illuminance produced on the inside surface of this hemisphere if it has a radius of 1.5 meter. So this radius 1.5 meter is the D. Okay, so there's 2 methods to obtain obtain the answer. Either you use the formula E equals to F over A, or you use the inverse square law. E equals to I over D square. So both of them will enable you to find the answer, which is 182.2 lux. Okay, so this is question 5. Your question 5 will use the formula of your inverse square law. So you're given known factors of I equals to 80 candela. The first A1, the distance is 0.8. The second distance is 3.2. So you substitute all this formula into the equation, the formula, and you'll be able to find out how much lux. The further the lamp is, or the table is from the source, the less lux you'll be able to obtain at the surface. So at 0.8, you have 125 lux, and then at 3.2, you get 7.81 lux. Okay, so question 6 is to find out the illuminance on the road surface directly below the lamp. So you're given 1200 candela, and you know that the lamp is 7 meters above the center of the road, which is 8 meters wide. As you can see here, the lamp is here directly at the middle of the road, and the road is 8 meters wide, 4 to the left and 4 to the right. So the illuminance directly below the lamp, which is what the question A is asking, is you just put in the formula in E equals to I over D square, you'll be able to get the answer, which is 24.49 lux. For B is to calculate the illuminance or at the edge of the road. So you know the road is 8 meters wide, 4 to the left and 4 to the right. So the most furthest away it is, which is 4 meter, you have to use the triangle law lah. So you can have a look back at the triangle law, how the methods are like. So if you put all of the factors variable into it, you get something like this, and then you get the illuminance. The answer is 16.03 lux. So you need to use the triangle law lah to solve this question. Okay, so final question, question 7. So you're given a point source which is 0.8 meters above the table, and the table is having 4 sides square, which is the same at 600 mm. So it's asking you to calculate the minimum and maximum illuminance values on the table. So when it's asking you to find out the maximum and minimum, you know that with the inverse square law, the further it is, the more distant it is the light source to the surface, the less illuminance the light source is able to give to the surface. So with that in mind, you know that the point source directly above the right angle, which is a distance of 0.8, that is the maximum illuminance, and the minimum is at the edge of this table. So with that in mind, you have to find the I. So you find I using the formula, and you get 198.94 candela. So you have to first find this, and then you find your E maximum, which is using the same formula. So as I said previously before, the idea behind it, maximum on this surface will be directly right angle from the source of light, and the minimum illuminance will be at the edge of this table. So Emax is equal to I over D square. This way you'll be able to get your maximum lux, which is 310, and the minimum illuminance is using the same formula, but you have an angle to it. So the same as previous, you have to use the cos theta formula. So you also have to find out the distance, the d, and then this way you'll be able to find out the illuminance is equals to 214 lux. So I hope you guys understand the method behind why the maximum illuminance and minimum illuminance is thought of this way and the method to obtain the answer. Okay, so if you guys have any question, so feel free to ask now lah. Okay, thank you guys.